in the 17th question, we again have a formula which is of pressure in terms of the distance, where K is the Boltzmann constant, theta is the temperature, and Z is the distance, and P is the pressure. We need to find out the dimensions of beta. So we see here that to find out the dimensions of beta, we first need to find out the dimensions of alpha. Now to find out the dimension of alpha, we clearly see that dimensions of alpha into dimensions of Z is equal to dimensions of K into dimensions of theta, because this whole quantity in the power of E has to be dimensionless. So we see that K theta, we need to find out the dimensions of K theta. In finding out the dimensions of K theta, we first find out where do we find something like K theta. So we remember the gas equation, which is PV is equal to nr theta. Now R is equal to K into Na. So we write this here to get PV is equal to N K into Na into theta. Now N into Na is a constant, it is dimensionless basically, into K theta. So the dimensions of K theta becomes equal to the dimensions of PV. Now we know also by the kinetic theory of gases that PV is equal to 1 by 3 mn u bar square. So basically PV has the dimensions of energy. So the dimensions of PV becomes ml2 t minus 2. You can also remember this in the future, that the dimensions of PV is equal to dimensions of energy. So the dimensions of PV becomes ml2 t minus 2, and that is also equal to the dimensions of alpha Z. So the dimensions of alpha becomes ml2 t minus 2 divided by m0 l1 t0, that is equal to ml, this is minus 2, this becomes mlt minus 2. Now we need to find out the dimensions of pressure. We need to find out the dimensions of beta. Dimensions of pressure is equal to dimensions of alpha upon dimensions of beta. So the dimensions of beta is equal to dimensions of alpha upon dimensions of pressure. Now the dimensions of pressure is equal to dimensions of force divided by dimensions of area. So we can write this as dimensions of force into dimensions of area in the numerator. So we feed in the values here to get dimensions of alpha. We found out as mlt minus 2 into m0 l2 t0 upon ml t minus 2, which was the dimension of force, which we remember. So these two cancel and we get the final answer as m0 l2 t0. So the final answer is dimensions of beta is equal to m0 l2 t0.